So 2 to the third power is 8. 3 to the third power is 27. 4 to the third power is 64. 5 to the third power is 125. 6 to the third power is 216. And we'll end at 7 to the third power is 343. The examples I'll use won't go past 7 to the third power. First thing that we need to look at, which is just this number over here, we call this an index number. Normally when you have a square root, the index number isn't there, but it's an invisible 2. Looking at this, it's simply asking what is the cube root of 27, and we look on our list, the cube root of 27 is 3, so the answer here is 3. So the next one, we see that 128 is not on our list of perfect cubes, and there's 2 ways that you can attack this. The first is to list the factors of 128. The second is, if you have this list here, simply divide the 128 by each of these numbers to see which one is going to result in 2 factors, one of which would be a perfect cube. If I divide 128 by 8, I get 16, and 16 is not on our list of perfect cubes, so the next thing we'll do is go to 27. When I divide by 27, it won't give a whole number, so then I go to 64, and 64 times 2 is 128. So I want to rewrite this. So I'm going to have cube root of 64 times 2. And when I pull the cube root of 64 out, I see that that's a 4. So I have 4, and then the cube root of 2 would remain underneath the radical. Next, we have the cube root of 192. Well, if I divide 192 by 8, what I'm going to get is 24, and 24 is also 8 times 3. So if I was to, 8 is a perfect cube, but 8 times 8 is a 64, which is a bigger perfect cube. So on the next line, what I'm going to write is cube root of 64 times 3. And the 64 comes out as a 4. So I would have 4 cube root of 3. Before we get to full-on algebraic cube roots, let's just take a look at a simple one here. So I have x to the third power underneath. Well, x cubed is a perfect cube. And if I take the cube root of x to the cube, it's just an x that comes out. The shortcut is to divide this exponent by 3 because of the exponent rule. So when I bring it out, it's just x to the first power, or x. Here under the radical, I have j to the 26th power. Now understand, when I'm multiplying, if I had j to the third times j to the third, I would add those exponents and get me j to the 6th. So to find multiples of 3 within this, I just simply divide it by 3. And just like in 5th grade, you have a remainder. So what I do is I divide the 26 by 3, and I'm going to get 8, which is 24 with a remainder of 2. So this becomes j to the 24th power times j to the 2nd power. And when that's simplified, j to the 24th power comes out as j to the 8th, because I'm dividing by 3, and the cube root of j squared remains underneath. Now combining what we just practiced with both variables and coefficients, now we'll combine them together for full-on algebraic cube roots. Super simple. So you just do it one step at a time. On the next line, I'm going to bring down the 7, and then under this, I'm going to have, instead of 40, it's going to be 8 times 5, because 8 is a perfect cube, times 5, x11, y11. Well, the 8 comes out, the cube root of 8 is a 2, so I bring out the 2, 2 times 7 is 14. Then I have the cube root of 5, and then x11 and y11. In both cases, what I want to do is I want to divide by 3 here, and if I divide by 3, I'm going to get 9 and 2, so I'm going to write this in expanded form. I won't do that for every problem, but just for this one. So x to the 9th times x squared times y to the ninth times y squared. And then the perfect cubes are the 9. So I can take out, so I have 14. The cube root of x to the ninth is x to the third. And the cube root of y to the ninth is y to the third. And then what remains under is 5x squared y squared. Okay, on this one, I'm going to do something a little bit different just so that you can see one other way of understanding the exponents of what's under the radical here. So 162, I would start on a calculator doing 162 divided by 8, and then 162 divided by 27, and then I find out that it's 27, which is a perfect cube, times 6, and then I have x to the 8th, y to the 5th. So now in the next line, I'm going to do 4y squared cube root. I have 27 times 6. This x would be x to the 6th times x squared times, and then this is y to the 3rd times y squared. Now I'm ready to pull some pieces out. So the cube root of 27 I see on my list is 3. So 3 times 4, I'm bringing the 3 to the front, so it becomes 3 times 4. So then this is 12. I'll leave off the y squared for a second. The x to the 6th comes out as x squared. X to the second power is the cube root of x to the 6th. I've crossed that off. Y to the third power comes out as y to the first, but I have a y to the second, so I'm going to do y to the second times y to the first. I add those exponents, that's y to the third. And then what I have left under is the cube root of 6x squared y squared. Okay, with this is the last example, and if you like, you can pause the video at this time and try to work it out yourself. If not, just follow along. Okay, so I have x on the outside, and inside I see that I have a perfect square. 8 is a perfect square, so I can bring out the 2. When I bring out the 2, it's going to be 2 times x. So on the next line, I'll do 2x radical, and then the 8 is gone, and then I have x4, y5. Well, in both cases, I want to divide, and I'm going to leave, when I divide, I'm going to have the remainder underneath. Now, reminder, to find the perfect cubes, I'm dividing by 3. So if I'm starting with x to the 4th and I divide by x to the 3rd, what I'm going to get is x to the 1st. That'll stay under the radical, and the x cubed comes out. So I'm going to have 2. I have x to the first power, and I'm taking out an x cubed, which is going to be an x once it's out. So this becomes x to the first times x to the first, which is x squared. And then underneath, this is x to the third times x to the first, so the x stays underneath. And then same thing with y to the 5th. I'm going to divide by y to the 3rd. I'm dividing those exponents, and I get y squared stays underneath. And y to the 3rd comes out as just y to the 1st. That'll be the last practice problem that we're going to do. But if you need additional practice problems, just comment below asking for a video with that, or if there's a video that you'd like made on any topic, I'll make the video if you post below. Please like and share the video.